Okay, so let's talk about projectiles part 2. I think these are type 2, am I
Did you
right?
print that off for me?
No, I didn't. Okay, so I don't remember the type number because I just sort of think about them as in like visual types. AJ, you with us? Okay, so I like to think of this as how I threw a guy out at second base. So like it's a horizontal, plane, flat ground, right? Throwing a football kind of thing, right? Baseball. Yesterday, what's that?
We have to memorize the type.
No, of course not. Just we have to be about like know how to solve it. That's all.
Oh, okay.
Yesterday we dealt with ones like this, right? Now yesterday the ones like that. What was the initial vertical velocity? 0. And now if we're throwing at an angle, it's going to have a vertical velocity and a horizontal velocity to begin with, right? So that's what makes it, I guess, slightly more challenging. Okay. So here I found this. So I like to show people this. And I always forget how to use it. Oh yeah, you can move the gun, or you can do this. That's right. Okay, so we're talking about. I don't have my firearms acquisition license. Kind of scary. Were you scared there, Riley, right in front of you?
Yeah.
How do I reset this here? You're having flashbacks.
Yeah.
I guess that's as high as I can go, it looks like. But that's what we're talking about, right?
No.
So,
Yeah.
what's that?
That's not a power.
No, it's not recovery. What's that distance called? The sideways distance. What do they call it? Range, right? Where is the velocity at its slowest?
At the very tippy top.
At the very tippy top. Why is that, Riley?
It's... I don't know.
At the very tippy top, it doesn't have a y, it only has an x. And that x, does the x velocity stay the same throughout?
Yes.
It does, we ignore our resistance, but the y velocity goes down to 0 and then negative, I guess, right? Okay, I think we're all good here. Okay, so consider a projectile like a bullet launched at some angle. This is just kind of review thinking questions. Let's hit the start assessment here. So true or false? True or false, the vertical acceleration remains the same throughout. And again, I'm just coming back to these and reviewing some concepts. Vertical acceleration remains the same throughout. Is that true or is that false? T or F? Yes, you have a T and an F.
What are you doing in that
Picked up a shift. A guy named CJ.
Dawson, I haven't checked on those checks yet, but I will before the end of the
Check.
True or false? The vertical acceleration remains the same throughout. We're waiting on you, EJ. Not trying to single you out, but, you know. You're the only one.
He's not even in the class yet.
Well, he must because he signed in. And we're back from commercial break, Riley.
Hey.
Megan will be real happy to. Oh, yeah? Okay. Let's see the answer. Yeah, no, my goodness, you guys. What?
See, I drove around you. We would know what.
Yes, but this doesn't say y velocity. It says acceleration. Vertical acceleration. In other words, what do we call the vertical acceleration? We call it gravity. I'm trying to get out here that you have to read carefully and slow down and think.
You got me.
Here. I'm not trying to trick you. I guess I'm throwing tricks at you on a low stress, low consequence kind of test, if you will, right? This one doesn't count for anything.
My stress is high.
Okay, well, let's see how number 2 goes. True or false? The horizontal velocity remains the same throughout. The horizontal velocity. Horizontal velocity remains the same throughout.
No, I knew this.
That previous one did say acceleration, right? Yes, it did.
Was that right yet or no?
No, Brett's only expensive.
What?
What's wrong?
Gotta fix the bridge.
Oh, okay, I'll fix it.
I bet you those two need to be switched.
EJ, yeah, you're right. EJ?
Yep.
Once again, not trying to single you out, but
And we're back. I'm just kidding.
and we're back again.
Oh my God.
7th pass.
Horizontal velocity. The speed remains the same throughout. That's one of the key points of this whole unit.
Wouldn't the acceleration stay the same too?
Horizontal velocity, the horizontal speed.
There is no acceleration. It's always zero.
Horizontal.
But I don't understand.
Oh, because okay, I got three people talking at the same time.
There's nothing.
Go ahead, Daniel.
Well, then if it's only gravity pulling it down.
Yeah.
But that has nothing to do with the speed of the horizontal.
Exactly. Holy crap. Pac-Man.
Will it not ever slow down?
No.
It doesn't have to slow down before it hits the ground.
No.
Or is that-
That's the. In fact, it speeds up. I just spoke to Riley and said the minimum speed is at the tippy top, is what he used for his right.
Tip it down.
Right? So let's say that it's moving at a muzzle velocity, we'll say 10 meters per second right here, right? So it's 10 meters per second, but as it gets to the top, the horizontal has stayed the same, but the vertical has gone to
0.
0, so its overall speed is no longer 10.
How is the...
What, okay, let me ask you this time. If I throw the ball up and down, the velocity changes, right?
Yep.
Obviously. What is changing it? What force?
Gravity.
Gravity. What's going to slow it down sideways?
Gravity.
You're a liar.
Getting nothing except for air resistance.
If we ignore air resistance.
Well, then nothing.
Okay? And the problem with including air resistance is that like, when we do gravity, we know it's always 9.8, but the wind could be any number, right? And there's no way we can solve a problem for the wind because we have no idea what it's going to be.
Unless you do it.
So we just say, well, we're going to ignore it.
Will never resolve them with wind?
Not entirely. When we do the projectile motion lab, we're going to actually count for it to make it work. But I've got a really cool little trick to make it work.
Submitted.
Okay? But generally, any question on paper, there's no wind or wind.
You
Okay?
So if the vertical acceleration, like if it didn't like have to drop, would it just continue at the same speed? Like if gravity wasn't...
Yes. Because what did Newton say? Objects in motion stay in motion, right? So the ball.
If you throw that ball, it's going to stop.
Only when you apply force to it.
So
It didn't stop until it touched you, did it?
Okay, if you go outside
Uh-huh.
and you throw that ball in the middle of the football field, it is eventually going to stop and hit the ground.
Right.
Nothing is
ground-
slowing it.
but it's gonna hit- it's gonna hit
slowing
the-
it-
it's gonna
slowing
hit the
down.
Gravity's
That's
gonna
that air
pull it
resistance,
down.
right? And to make it simpler, we have to remove that air resistance. Otherwise, if the wind's blowing extra hard, like if I go out and throw into the wind, it's going to drop faster than if I throw with the wind, it's not?
Yeah.
And that wind could be gusting, could be different every day,
Let's do indoors.
right? I mean, even indoors when I go like this, it eventually it slows down. Yes, I know in real life it will slow down, right?
But this is just equation.
This is just, the theory behind it.
Hits the ground.
Okay, so here's sample number 2. Yeah, you should probably write this down. Okay? This one here is pretty straightforward. It's generic. There's no sort of fancy, no movies that go with it, no pictures, just boring old math. Sorry.
I never did this
The
yet.
ball is hit at an angle of 30 degrees and leaves the bat with a velocity of 40 meters per second. So the first thing we're going to do is find VV.
Up and down.
I'm going to do a 10.
What can you make out of that angle in that line?
Triangle.
Mm-hmm.
Okay, I got it now. Yeah, have some notes.
Oh.
Oh, I'm still recording. I should have hit pause there. Sorry, Megan and others. So you need to find, this is the clicker one, right? You need to find VV, or I guess if you prefer, VY, which is the Y component, the vertical component of V. I like VV, but I've kind of gone with this X and Y thing lately, so I don't want to.
So we're looking at 20.
You're looking for, we've done components already. This is no different than unit number 1, right?
Is it 20?
Right? So VV is opposite the 30 degrees.
I'm gonna put it.
You've definitely done these things before.
Now this is easy. It's
Yeah.
just repeating.
It is. Well, you know what? If you stop and you look at all this stuff, there is way more repeating than you realize.
I don't know what the formula is.
It's just you change the letters.
Yeah, you're absolutely right, Ronnie. It's just the same concepts, just packaged up a little different. It's kind of like leftovers for supper.
They don't taste.
Sometimes leftovers are better.
Yes.
Mm.
I like leftover chili. It always has, I find, better taste on day 2. Pizza? Yeah.
Soup sometimes.
Yeah.
I like everything fresh.
Chicken's good.
Even I don't mind a cold hamburger sandwich.
Nope.
No? Okay. I like just the meat, 2 slices of bread, a little bit of mustard.
Taco seasoning.
I could get
Yeah.
that.
These
Absolutely.
might include units.
You can't put
I could eat
units.
it cold, yeah. I do that.
Taco seasoning.
Oh yeah?
That's taco.
Oh wow.
We're waiting for the initials. Oh, and I didn't hit pause. The answer is 20.
Okay, so I have a question.
Okay, how about I show you the answer?
I did that.
V sine theta, right?
Yep, that's
Opposite.
I'm not sure what the V to like where to put if it was FA and that's like
Yeah,
fluctuation.
it's the same as horizontal and vertical components of forces, right? Same as vertical and horizontal components of velocity vectors. In fact, this is a velocity vector.
What?
Feels like this thing's sliding around on top of my head. No, stuck pretty good.
Like I said, it's gonna hurt when it comes off.
I don't think so. That staple's not too deep.
Bitch did it.
Did you know how they put Indiana Jones' hat on in the movie? Like the actual, like Harrison Ford? In the movie, they actually stapled the hat onto his head
What?
with a stapler.
No.
That's why it stays on during all the action scenes.
No, they didn't.
They did. Google it up.
Okay, so that's.
Can you Google it?
Well, then when he loses his hat, what?
You're finding VH now.
Which decimal point?
Ooh, good question.
I want to keep my.
1 decimal point.
Are you sure?
No.
If I get this wrong, because you
What?
care about the best.
You're gonna rip my toupee off.
That'd be pretty funny if you want to.
Actually, yes, because I want it off, and I probably can't do it myself. So.
What is last class today?
Halloween doesn't stop.
At the Halloween store in Brandon, I saw it and I went, I'm spending $10 on it.
How many decimals did you say?
I said 1. I got a severe eye rolling at home when I pulled it out. Apologize if you're getting it wrong because of the decimal. 34.6! Hey, everyone got it! Woo!
We did it.
I was supposed to have an answer and interrupt you.
Sure. Or maybe not. Well, I don't. Here's one.
Yeah, I can make my own double-sided tape.
Okay, moving on. Now, what about the time of rise? How long does it take for the ball to go to the peak?
I've never done this before.
Yes, you have. Well, maybe not in this instance, but just apply what you already know to a new situation. That's all you're doing. I mean, that's all physics really is, right? Is applying what you know to new situations. So, first of all, the multiple choice question, we're going to use VF equals VI plus AT. And the VF is going to be
Zero.
Y0.
Because it lands.
Because the vertical component goes to 0. But my question first is, which one do we use for the VI? The 40, the 34.6, the 20, or minus 9.8?
20.
The 34.6.
Oh, wait. No, because that's horizontal.
No.
Would you use
Yeah.
Which one do you use for VI?
Then yeah, the
20.
Okay.
Yeah, it would be 20.
Go ahead, punch it in.
No.
I dare you.
That's the vertical component. While talking about the PQ, they're independent of each other.
Are we talking about vertical stuff?
Well, we're not asking a question.
Yeah, then.
No, you're just answering which one you use for VI. You're typing in A, B, C, or D.
I just put in B.
Locked in.
Oh.
No, we don't actually have to stop. They do.
Because everything gets to the top.
That's what we're going to find out, but I want to know which value do I use for VI. Right? Your possible answers are A, B, C, or D.
Can I write this formula down?
Absolutely. You should have that formula already. That's one from like the first unit. Have you seen any formulas yet this unit that are new?
This one?
And you're not going to.
Do we?
Yeah, this is like one of the first ones.
The answer is C. Why? Because that's the
Vertical.
VV. That's the one that determines how high up it goes, how long it takes to go up, right? Remember I said you use the vertical component for everything that's related to the rise, right? So this is a vertical velocity. This one has to be vertical. So it's going to be 20, plug that in, and you end up with 2.04 seconds.
Okay, I understand now.
Good?
And this is just finding vertical stuff.
Just finding vertical stuff. Time of rise. So what do you think's next, DJ? What's the next question I'm going to ask? What's the next in succession, you think, eh? How long? Distance?
See how long.
Coffee Tim.
How high up does it go? Yeah, I haven't made them big to see for you to see. How are we going to do height of rise? How am I going to do?
You gotta find time.
Do I have the time up already?
2.04.
I got the time up, 2.04. So are there two different ways to do it?
Yeah.
You betcha. You could use this one. VS squared equals VI squared plus 280. Old formula. 20 squared plus 2 times minus 9.8 times D. D is 20.4.
What's the other way?
What is the other way?
D
You
equals
guys, you guys, you want.
Do you know the A?
Yeah.
Why?
Because it's on Earth. Gravity.
And it's vertical, right? It's on Earth, it's gravity, and it's vertical. Exactly.
So to you, which one would you do in a situation like this?
Well, I mean, a lot of people like this one because it's just D equal, so you can punch it all into your calculator all in one shot and be done, right? This one here, you kind of got to do a little bit of maneuver.
I like the maneuvering better.
It's whatever your personal preference is.
Oh,
There's no preference. You can pick either one.
I mean, this one, there's more typing to it, right? Now, actually, did you need to do part C to do it this way? You don't need to do you don't need to know the time, right? So this one eliminates that part C.
clear writing.
Okay, so that's height of rise. Okay, now what about the time of fall? How long does it take? How long did it take to go to the top?
2.0.
2.04.
Wouldn't it take the same?
Would it be the same, Danielle?
Yes, it would.
Yeah.
You saying that?
Yeah.
Do you have a reason?
Well, the vertical shouldn't change.
Well, look at the time of the drop.
Acceleration.
The acceleration's exactly the same. Could we also figure out how long it takes to fall 20.4? Because that's how high it is, right? We just figured out that it was 20.4 meters high, two different ways. You think it's going to be the same?
Yeah.
Gee, what do you know?
I like the other formula.
Is the time up always going to equal the time down?
Yeah.
Like with wind resistance.
Well, if you sell it, if you throw
If it's on level ground, says AJ.
Always throw off.
Is he true? Is he right?
Yeah.
Is he true?
He's a wizard.
So TF equals.
Is the time up going to equal the time down?
Yep.
When it's on level ground. Or Some might say when the vertical displacement is
Equal to,
0, right? The overall vertical displacement, right? Yeah. So the time up is going to equal the time down. Now, does that mean, hold on here, does that mean that it's going, if I launch it, what was our vertical component to begin with, 20?
Yeah.
It was 20 was the vertical component, right?
Yeah.
Does that mean that it's going to be going 20 down when it hits?
Mm-hmm.
yeah,
Like plus 20, minus 20?
yeah.
Should it be, Danielle, you think?
Well, it would be going minus 20 until you're at the bottom. Because it
At the exact bottom, right?
Yeah.
But, okay.
Or, like,
Okay. What about the total time of flight?
Don't break that stomach.
Just add them together, right?
No.
You could just say time up plus time down, total time of flight 4.08. Now, what do you think is this fine print I got over here on the left-hand side?
Some weird formula.
Well, sort of. But I'm going to do a little foreshadowing for
Shadowing.
the big day, the big daddy projectile
Big Daddy.
lesson. Would you say that the vertical displacement was 0 for the entire trip?
Zach, nice to meet you. Speak.
Okay, good. Ask him if he locked the door back there. Like the rock and roll room. Thank you.
The vertical and the displacement.
Would the vertical displacement be 0?
Yeah.
Because it would be exactly the same height that it was before, right?
Mm-hmm.
Okay, so the D would be equal to 0. So in other words, you could do this. You could say that the vertical displacement, let me just make that a bit bigger, the vertical displacement is D. What's the initial vertical component? 20 plus 1/2 minus 9.8 t squared, and you'd end up with 4.9 t squared minus 20, which is a quadratic. Oh, you guys are mispronouncing it. It's yay, it's a quadratic. Now, do you remember? Here's again a repeat from before. Remember when we did Fred and Barney? And we factored out a t, right?
yeah.
T, and then I'd be left with 4.9 minus 20t. No, 4.9
Yeah.
t.
Well, I'm confused.
4.9 t minus 20. I'm just factoring out a t, which means either that t is 0 or 4.9 t minus 20 is 0, which makes t equal to 20 over 4.9. Jeez, you're awfully picky.
No, the top.
Oh, the top.
Thank you.
Or
Thank you.
I could read.
Sorry.
Don't
Like gravity?
Ah.
20 over 4.9? Someone please, with a calculator? What is it?
4.08.
Well, what do you know?
Oh, how did you find out that?
Well, what do you know?
How did you do that?
Could you also...
No.
no. I hate quadratic.
You could. No, because you don't have to.
I punch those in wrong every time. Can't do it.
But you don't.
Do you have to?
No.
No! Can you just do it this way?
Yeah.
Yeah, but I want to show you this way because...
Because the vertical,
Or the other one.
plane,
You're
or the
gonna
cliff.
eventually
There
have
we
to do
go.
that.
You have to do like plus or minus, what's the other one?
Dang.
Dang.
It'll be 0, right? 20 minus 20 would be 0 over 9.8. So what that means is that a time is equal to 0, it's on the ground, and at time 4.08, it's also on the ground, right? But the d is equal to 0, which means you can factor, but the d is equal to 0 when it's horizontal flat ground. If you're on a cliff, there is a vertical displacement, isn't there?
Oh, so you can find it.
More on that in a few days. Just a little bit of foreshadowing. Please don't write all this down.
I did.
I didn't write.
Don't do that. It's not worth it. Okay, what about the range? How far away does it land? Is the VH a constant 34.6?
Yep.
Huh? Because the VH is the horizontal component of the VX, right?
Oh,
Remember that whole no air resistance conversation that we had over here?
Yep. And then
So
Indiana.
constant 34.6, yeah, and then Indiana Jones. And what's the time, total time of flight?
4.0.
4.08. Is it just this kind of thing? How come there's no A value here?
Because
Because there's no acceleration. There's no horizontal acceleration. It's constant.
So if it's asking for the range, that's just
Horizontal is-
So then you would only use your velocity and force.
Correct. Yeah.
Nope.
Any new formulas that you've seen up to now?
No.
All I've really done in expanding your knowledge base is tell you when it's 2D motion, you should separate the horizontal and vertical. And then I've applied what you already know to these situations. That's all we've done. Right?
Yeah, but I wasn't here yesterday.
No. None of this is from yesterday. Well, I mean, it's a bit of a continuation from yesterday, but the overall knowledge that you have is V equals D over T, the kinematics equations, basic common sense. There's nothing new here. Okay, now there's a lot here. All I'm going to ask you to begin with is, I'm going to ask you this question over here.
Is this the new VI?
Will the final velocity be different from the original launch velocity? Like when it hits the ground, will that be different or the same as the original? What was the original?
It was like,
The original launch speed was 40, right? So will it hit the ground going 40?
Yes.
yeah.
Will the final velocity be different? So yes, it would be different. No, it would not be different. And I was on pause that whole time.
And we're back.
Were you? Oh.
How far back do I go? I don't know.
We could
Redo the whole
pause
thing.
Or not pause, like.
I could, but there's all those big blank spaces, right? Like where we're waiting for EJ to punch in his answer and stuff like that.
It's okay, you can mess up once. Like, no one watches except for Megan Bruno.
Hi, Megan. What was I going to say?
I hope you heard that.
Oh, Danielle wanted to know if it was on a cliff, if the up speed would be the same as the down speed. And what do you think?
No.
In fact, it would be, if I do this, if I draw an imaginary line out there, that speed right there would equal the speed right there, would it not?
Yeah,
And then would it not continue speeding up?
get faster because the acceleration.
I know what I was going to say too. You know, you see in the movies, or the guys, the revolutionaries, and stuff, riding riding horses, shooting guns in the air.
Yeah.
Right? How fast is that bullet coming down? Exactly the same speed that I left the gun.
Oh. That's
They'll
dangerous.
be dead when
So they should be shooting down.
Okay, but most of the time they shoot it and then they run.
Okay.
Yeah, but I
So the moral of today is if you shoot a gun in the air,
It's gonna come right back.
don't come back to where, or don't stand where you are. Go somewhere else.
Don't shoot it straight up.
Yeah.
Shoot it on an angle.
Yeah, shoot at an angle.
You shot it straight up.
Don't hit it.
I guess that's it. That's all I got.
That's ridiculous.
Okay, you got a few minutes left.
Wind.
Yeah, I think I'm going to give you a work period tomorrow. We'll do the coffee cup target practice lab on Thursday. We'll try and do the Big Daddy projectile stuff on Friday. We got to do the Hot Wheels stuff. No, we got to do the Hot Wheels stuff for a couple days. But if we could have a test the end of next week, that would be real good. End of next week.
Eat that.
If you have Hot Wheels track or Hot Wheels cars, I would appreciate that.
Talk to Luke.
I bring